Hello, my name is Nyayik Yasir Shaukat, and today I'm going to talk about a mathematical concept that is progression. We are going to talk about progression. So, have you heard about uh, patterns surrounding you? Have you heard about things that have a very symmetrical pattern, like a sunflower petals? Have you ever checked the sunflower petals? They have a pattern. Have you seen a honeycomb? You will see that hexagonal combs are continuously made and they form a beautiful pattern. So in nature there are patterns. You can look for them, you can see them, and you will find there are a lot of patterns in nature. So now we are talking about patterns. How does this help us? Patterns create symmetries. Pattern create a way forward. When we check a pattern, we can understand a lot of things by that. So similarly in mathematics, these patterns help us to understand a lot of things. And when we see patterns in numbers, and that helps us to deduce other numbers, and this helps us eventually to form different series, and that helps in mathematics a lot. So coming to our topic, we have progression. What I am going to speak about is progression. So what usually we have, if we suppose take an example, we have this first example. If we take, we have 4, then we have 4 square, then we have 4 cube, then we have 4 raised power 4, and this goes on. But if you will check the digits at the units place, they will be 6, they will be 4, they will be 6, they will be 4, they will be 6. You can see the pattern, you can understand the pattern, and this pattern helps a lot in physics, in mathematics, and aerodynamics, lot of fields. So you can check, this is the basic example, you can see here a pattern. Now coming to second, let's suppose I am working in some company and I have a salary of 10,000, and after every year they increase 2,000 to my salary. So what will be the progression? Or series? It will form like this: 10,000, 12,000, 14,000, and so on. So what are we doing basically? What are we doing? We are adding. Similarly, we can take an example of subtraction. Like I am saying here, I have to pay to a bank each month 200. Each month I have to pay 200. I have 1,000 rupees and I have to pay each month to the bank 200 rupees. So it is 1,000, now it's 800, and then it's 600, and this is so on. So actually what are we doing? We are adding. We are adding something. We are adding a constant figure, constant number to something, and this forms a progression, arithmetic progression. We say it AP. What we say? AP, or arithmetic progression. And in this AP, what is the main thing we have? We have a constant thing, constant number, and constant number is added or it is subtracted. and this makes a progression, and this constant number is said called common difference. What is called common difference, and it's denoted by D. So in a progression there are terms. Each number is called term. This is a first term, this is a second term, this is a third term, and so on. So each number is called a term, and a constant figure that is added or subtracted is called common difference. And so if we see how our progression is formed, if we have a number a, I will add to it a plus d. This is the second term. Now I will add it one more d, that's 2d. This is the first term, this is the second term, this is the third term. You are getting it? Now you can see more clearly what I am trying to say. So the first term is a, the second is a plus d, the third is a plus 2d. These are the terms. So what will be the nth term if we move like this? See, a plus nothing is the first term, second term a plus d, third term a plus 2d. Actually it is a plus 3 minus 1 of d, third term. Similarly this is a plus 2 minus 1 of d. If you go on, the n term will be a plus n minus 1 of d. This is the nth term, the last term of the progression. What is it? Last term of the progression. What is the n term? A plus n minus 1 d. So this forms a progression. A progression having a common difference d, first term a, and this nth term is this. Now there are a lot of things we can do to this series. We can sum it up. Sum is the most easiest thing we can do to a progression. We can sum it in 2 minutes, and the formula we know, S of n. And how we will derive that formula, here I am not going to talk about it, but I am just writing it down. Go S of n, sum of n terms is n by 2 into 2a plus n minus 1 into d. This is the sum of the n terms. You get it? So a progression has a common difference, a first term, a last term. Some may not have a last term. They are infinite terms, and somehow they have finite terms. So these are finite terms, and this is their sum. Likewise, we can even sum the first n natural numbers. First n natural numbers. First n natural numbers. What is the sum? N plus 1 divided by 2. N into n plus 1 divided by 2. This is the sum of the first n natural numbers. So progression gives us a pattern, and this pattern helps us to deduce the sum, provides us deduction of sum of first natural numbers, squares of natural numbers, a lot of things. Then we have an arithmetic progression, we have a geometric progression. So we will talk about that later. Thank you. Have a nice day.